Now that we've defined the person class, let's move on. Let's suppose here at MIT we want to keep track of MIT people who are persons in all respects. They have names and birthdays like every other person, but they also have a new attribute. We're going to then use inheritance to build a MIT person class that will inherit all of the person properties, and in addition provide for this new capability. And we'll also add some new interface methods. We'll make sure that we can assign ID numbers in sequence, so as we allocate people, they'll get a unique ID number in order. And then we'll provide a way of programs to get a hold of the ID number. And finally, we'd like to sort MIT people not by their name, but by their ID number. Let's look at the code. So here's my idle buffer with the definition of the new MIT person class. Notice that it inherits from person. So that means that the MIT person will have whatever attributes are defined below, in addition to whatever attributes were defined by person and then also by object, because person was a subclass of object. Okay. So what we see here is some of the usual method definitions, plus there's the definition of a data attribute called nextIDnum. And that's something that all MIT persons will have access to and share, and we'll see how that works as we talk about how new MIT persons are initialized. So let's go run some code. Okay, so person 1 is going to be an MIT person named Chris, and person 2 will be an MIT person named John. And just to have an example, we're going to make a second MIT person named John. And finally, let's have a fourth person, just a regular person now, not an MIT person named John. So we have 3 Johns and a Chris. Okay, so if we go off and ask ask Python to print what an MIT person looks like, it prints out my last name. And the way that worked, of course, is that since there's no definition of a string method for an MIT person, the system then went and looked to see if there was a definition of the string method for person, and in fact there was, and that was the method that got used. When I created an MIT person, a couple things happened. Let's look at the init code over here. So the first thing that we do when calling the init method of MIT person is to actually go off and give the person init method a chance to run. So we initialize all the attributes of a person, and then we'll come and continue by initializing the special attributes of an MIT person. So this call here is basically saying, look, I'm going to go call the init method of an MIT person, and I'm going to pass in the name, the object that I'm trying to initialize, and of course the arguments that the person initialization needs, which is a name. And then let's look at the next 2 lines because they're sort of interesting. So I'm setting up an instance variable now for MIT persons, of this particular MIT person called IDnum, and I'm using the current value of MIT person dot. So I'm reaching into the class, MIT person is the class, and I'm reaching in to the data attribute, in this case called nextIDnum. So I'm taking that integer value, which the first one will be 0, and using that to initialize ID number. I then reach back into the class and increment the ID number. So every time I'm initializing a new person, I'm not only setting up, the values of information inside each MIT's person object, I'm also reaching back into the MIT class for a shared variable, one that's shared among all MIT people, and using that as sort of a global resource to allocate unique ID numbers. So what's the difference between, this is called a class variable, what's the difference between a class variable and an instance variable and a global variable? So if I had made this an instance variable, if I had said self.nextIDnum down here, what I would be doing is I would be accessing an ID number for each instance, but I wouldn't have no way of sharing information between one instance and another. So instance variables are unique per instance. And so if I'm trying to do something that's shared by all members of a class, I can't make them instance variables. Why didn't I make it a global variable? Those are all shared. And the answer is I could have made it a global variable, but now next ID num would be a name in my global namespace that everybody would have to understand is a resource that's being used by MIT person. So it sort of breaks the modularity. There was a special shared variable that was needed for creating MIT people, and it will really start cluttering up my global namespace if I have to declare everything that needs to be shared by everybody. I'd really wanted to do something that was just shared by MIT people, so that's why I made it a class variable. Okay, so let's go off and see how well our ID numbering system works. So I can go off and ask for the ID number of person 1, 0, and the ID number of person 2, 1, so forth and so on. So that all was working fine. So let's finally test our less than comparator. That's what we'll be using for sorts. So let's find out, is person 1 less than person 2? And remember that the ordering of MIT people is determined by their MIT ID. In fact, person's 1 ID was 0, and person's 2's MIT number was 1, so person 1 should be less than person 2. Okay, how about, is person 3 less than person 2? So is the third person I allocated come before or after the second person I allocated? And the answer is, well, it doesn't come before. It only comes after. So person 3 is less than person 2. Now, person 4 is not an MIT person, just a regular person. So what if we ask that person 4 is less than person 1? Well, that returned false. So let's think a little bit of how that worked. So person 4 is a regular person, and person 1 is an MIT person, who, by the way, is also a person. So if I go is instance person 1 a regular person as well as an MIT person, the answer is yes, they are. So what's going to happen here is that, remember before when we were discussing how sorting worked, Python changes this Python expression into a call of the special less than method of the first argument. So the less than method of the first argument is the less than method associated with person, and so it's doing the sorting by name. So it's really asking whether the name John comes before or after the name Chris, and the answer is, in fact, it doesn't. What happens if I do this the other way around? Can I say, is P1 less than P4? Ooh, I get an error there. So let's think a little bit about what that error is telling me. It's really saying to me, it's pointing out that an attempt to reach into a person object, I'm trying to get the ID number of a person object, but ordinary people don't have ID numbers. Only MIT persons have MIT numbers. And so what happened was we did the same sort of operation. What we did is we called the less than operator of the first argument. Well, the less than method of the first argument here, I mean, this is an MIT person, so we'll be using this definition of less than when trying to do this comparison. And this code actually assumes that the other argument to less than is, in fact, another example of MIT person. And where the code failed was right here on this line when it tried to get the ID number of a regular person, and that regular person object had no such attribute.